Objective: to know the discovery of protons. We know that the discovery of cathode rays led to the discovery of negatively charged electrons. This, however, did not justify the fact that an atom as a whole is neutral. Scientists then contemplated the possibility of the presence of positively charged particles in an atom. Subsequently, the discovery of anode rays led to the discovery of positively charged particles called protons. Anode rays were discovered by German scientist Eugen Goldstein in 1886. Let's understand the experimental setup of Goldstein. Goldstein used a gas discharge tube which had an anode and a perforated cathode. At a pressure of 1 mm of mercury, cathode rays were observed to be moving from the cathode to the anode. He also observed a faint luminous glow extending backwards from the holes in the cathode. He called these rays as anode rays as they traveled in a direction opposite to that of cathode rays. As these rays passed through the holes or channels in the cathode, these rays were also called canal rays or channel rays. When an electric field was applied perpendicular to the direction of the rays, they were found to deflect towards the negative plate. Similarly, in the presence of a magnetic field, they were found to deflect towards south pole of the magnet. Hence, these rays were believed to consist of positively charged ions. How are these ions formed? Electrons coming from the cathode collide with the atoms of the gas in the discharge tube, causing the atoms to lose electrons and become positively charged ions. These ions, by virtue of their positive charge, travel away from the anode and pass through the holes of the cathode. Is the E/m ratio for different anode ray particles the same? Let's find out from the following table. It is clear from the table that the charge to mass ratio E/m is different for different ions. It was also found that hydrogen has the highest E/m ratio. Hence, hydrogen gas was found to produce the lightest and smallest positively charged ion. This smallest positively charged particle was termed as proton. The magnitude of the charge on the proton was found to be the same as that of electrons, but the charge on it was positive. That is, plus 1.60 2 into 10 raised to the power of minus 19 coulombs. The mass of proton was found to be the same as that of hydrogen atom, that is 1.672 into 10 raised to the power of minus 24 grams or 1.00727 AMU. Let's summarize. Eugen Goldstein discovered protons from the anode ray experiments. The magnitude of the charge on the proton is the same as that of electron, that is plus 1.60 2 into 10 raised to the power of minus 19 coulombs. The mass of proton is 1.672 into 10 raised to the power of minus 24 grams or 1.00727 AMU.